In this video, we're going to discuss types of autoscaling, Google Kubernetes Engine. So the first type of autoscaling that we're going to discuss is cluster autoscaler. Cluster autoscaler scales the number of nodes in the cluster based on the overall resource demands of the pods. And it's also a best practice to set the minimum and maximum number of nodes. This constrains the autoscaling. So let's draw this out. So if the blue box represents the cluster and the pink boxes represent the nodes in our cluster, then cluster autoscaler can change the number of nodes, basically. Here it's increasing the number of nodes from 2 to 3, but it could be decreasing the number of nodes or increasing them even more than this. So that's cluster autoscaler. Now we've also got horizontal pod autoscaler. And with horizontal pod autoscaler, it's in the name, it scales the number of pods. Importantly, it does not restart pods. So if you see this as an option on a GCP exam, and one of the options is to restart the pods with horizontal pod autoscaler, that would be factually incorrect. It can scale by memory, CPU, or custom metrics. And just note that it is incompatible with some stateful workloads. Yep, it's incompatible with some stateful workloads. So let's draw this now. So here we have our cluster. So with horizontal pod autoscaler, our diagram here shows that we've got our cluster in the blue. We've again got our nodes in the pink. I figured out that I can just use boxes for these. And then within each node, we have one or more pods. And horizontal pod autoscaler changes the number of pods. So we see after horizontal pod autoscaler is applied, we can write horizontal pod autoscaler here. Each of the nodes has 2 pods instead of 1. So again, this could be an increase in pods, it can be a decrease in pods, it can be even more of an increase than we're seeing here, but you get the idea. And the last one that we're going to talk about is vertical pod autoscaler. So we talked about horizontal pod autoscaler up here. Now we're going to talk about vertical pod autoscaler. So what do we need to know about vertical pod autoscaler? Vertical pod autoscaler scales the compute and the memory of individual pods based on their usage. Unlike horizontal pod autoscaler, vertical pod autoscaler may restart pods, and it cannot be done based on custom metrics. It has to be done based on the built-in metrics available. So let's diagram this out. Let's imagine here that within each pod, we've got a computer chip. We're just like a piece of hardware, right? So we are just going to represent it like this. So within each pod, we've got one of these to start, like this, smaller this time, right? So again, on the left, we've got our cluster, our node, and our pod. We've got multiple of them, 2 of each. But when we apply vertical pod autoscaler, then we have the same number of nodes in our cluster. We have the same number of pods in our cluster, but we get more resources per pod, right? So this could be more memory. This could be more CPU, more virtual CPUs. It really depends on how you set it up. But the point is that it scales the compute and the memory of individual pods based on their usage. So vertical pod autoscaler doesn't change the number of pods. It adds resources to the same number of pods, whereas horizontal pod autoscaler actually changes the number of pods, and that is the difference. And then we've also got cluster autoscaler, which scales the number of nodes, and it's a best practice to set the minimum and maximum number of nodes. And these 3, cluster autoscaler, horizontal pod autoscaler, and vertical pod autoscaler, are the types of autoscaling in Google Kubernetes Engine and that you need to know for GCP exams like the Professional Cloud Architect exam and the Associate Cloud Engineer exam. Hope this helps.